Okay, welcome Math 2. Here we are looking at today's work. It's going to be about piecewise functions. We're going to define a piecewise function. Here's a real loose definition of it. But we're just talking about a function that's chopped up into several different pieces. Okay, so it's not one single function that we're going to look at. It's actually several pieces at a time. Okay, now we're going to start with just looking at some examples. Right here, we have an example of a piecewise function. Notice it says f of x equals this piece on top whenever x is less than 0, and this piece on the bottom when x is greater than or equal to 0. Okay, so the first thing I want to recognize, of course, is that I've got two different sections of my graph. This first section here, when x is less than 0, I'm going to graph this line, x minus 1. So on this section, when x is less than 0, I'm going to graph x is less than, or x minus 1. Now, the second equation happens whenever x is greater than or equal to 0. So basically I'm going to have a left side and a right side of my graph. So let's graph the first one, y equals x minus 1. Okay, it would look like this normally, right? Normally that's what it would look like. But remember, I only want it on this section. So I'm going to graph only to there. And I'm going to, ooh, sorry, wrong button. Okay, I'm only going to graph to here, and then I'm going to erase the rest of that. I don't need those. Those don't happen. Now I switch to the green section, and I look at the green equation. Of course, that's negative x plus 3. So on the green section, I'm going to graph that. And of course, normally it comes up here, but notice that's on the yellow section, so I really don't want those. I get rid of them, and I go ahead and graph that line. Now, another thing to notice real closely is to pay attention to what has an open circle and what has a closed circle. On the yellow, I put an open circle on the 0, because if I look very carefully up here, it says that x is less than 0, but it's not equal to it. On the green, I put a closed circle, because on the green it does say that it's greater than or equal to the 0. To check out the domain and the range, for the domain I ask myself, do I use all of the x's that go to the left? And the answer is yes, they're all on this yellow graph. Do I use all the x's that go to the right? And the answer is yes, they're all on the green graph. And in fact, these two, this solid dot here fills in that empty hole there, so my domain is all real numbers. Now the range is a little trickier.
Kelly Quaker, please dial extension 3412. Kelly Quaker,
The range,
please dial extension 3412. Thank you.
Hold you just a second.
okay guys, sorry for those interruptions, had a little after school stuff. The range, again, we're talking about all the y values that are used. Well, the y values happen from here down. So these y's go on forever, and these y's go on forever, but it never gets above that y value right there. So we'll say that the y is less than or equal to 3. And again, I probably should have drawn those arrows on those. The end behaviors, I'm going to look down on this yellow one down here. As this yellow goes on forever, as my x's go lower and lower and lower to negative infinity, what happens to the y's? They also go lower and lower, so they go to negative infinity. On the other side of the graph, as my x's go positive, the y's continue to go negative. Alright? We're going to go through the same thing on this second one. Probably not going to talk as much, just going to let it play through. I'm going to divide it up into sections. That was a little fast, I know. And then the purple section. Now notice on this purple section, I actually don't use this. Even though I would normally graph these points, I actually don't use all of them, so I'm going to get rid of that one. Open circle on the purple because it's only greater than. Closed circle on the blue because it's less than or equal to. just like on the last problem, I use all of my x's to the left and to the right. And just like on the last problem, I use the range that goes up forever, but it never, ever, ever gets below that point, -5, so it's greater than or equal to -5. And behaviors here, as x goes to -infinity, y is going to positive. And here, all right. Now, what we're going to do here is we're going to write equations to match these, and then we're going to evaluate using these. We're going to start off writing them. Of course, writing them, I have to remember my function y equals mx plus b, because I do have lines. These are lines, and this is a line, so I'm just going to remember them. I'm going to divide it up into pieces. Notice that all the magic seems to be happening right in between these two pieces right here. Okay, so in purple, those are all the things that are less than or equal to 1, -1, excuse me. And in red, those are all the things that are greater than -1. Now I'm going to write my equations. So in purple, this is just a constant function. That's the function y equals -3. It's constant. There's no slope. And then in red, I use my slope-intercept form. I start at 1. I go up 2 over 1. So I end up with 2x plus 1. All right, that's my function. Now down here I ask you to evaluate. So what I want to know is what's the value of, when I plug in a 2, what is the value of the function? Oh. All right. I did forget about the domain and range. The domain, I think you can see again, it's everything left and everything right. But the range is a little tricky because I use from here all the way up forever. So I use all of the numbers that are bigger than -1, and that's what I said right here. But then I jump down and I grab -3 as well. So I have to mention both of those. Now, down here on the evaluate. All right, when x, what this says is when x equals 2, what is y? So I look at my function. When x equals 2, let's see, which one of these tells us when x is 2? Well, that's the red graph. So I can plug in a 2 right here. 2 times 2 is 4. 4 plus 1 is 5. Or I can read the graph. When x is 2, y is 5. So my answer here is 5. Same idea on -2. When x is -2 on the graph, y is -3. Or when x is -2, that's the purple, so y is -3. Either way, I get an answer of -3. And right here, I have to look very carefully when x is -1. So very carefully, I look when x is -1. Is it purple or is it red? And because of the closed dot, it's the purple one. So x is negative, or y would be -3. Same thing here. Which one of these, when I plug in a -1, will I use, purple or red? And of course it is purple. Alright, the second one, I'm just going to run through. I'll try to slow it down. You guys can watch that as it goes. When x is -2, excuse me, +2 right here, then I'm on the blue graph, so y is going to equal 1. When x is 0, I'm on the green graph, so x is -4. You can also plug in up here, because 0 is less than 2. I can plug in 0 minus 4 and get negative 4. And here on x equals 9, well, clearly 9's not on my graph, but if I keep following it, this arrow right here tells me that 9's up here somewhere, so it will continue to be on